These are called Lissajous Figures. I've got the Siglant on 500 kilohertz and the Adjulant 100 kilohertz. That's a nice display. The Adjulant will only go down to 100k. So what I'll do, I'll get another lead and use the Siglant only. That's 10 kilohertz and 25 kilohertz. That's quite good. You find that some of your controls in XY mode won't work. For example, the time division. That's a nice steady one. Let's play about with it a bit, make it move. So I know you put quite high frequencies in, 100 and odd megs, but you know, just use low ones and you'll get some nice displays. I'm changing just one channel. The other one's on 20, let me look. Yeah, the other one's on 10. Sorry, the other one's 21 at the moment. 22 and 10 kilohertz. 25 kilohertz and 10 kilohertz. 30 kilohertz and 10 kilohertz. 40 kilohertz and 10 kilohertz. I've just doubled the frequency. And doubled it again to 640 kilohertz against 80 kilohertz. It's quite an interesting one, that. I can't go lower on this Siglant than 1K per channel, and I forget it's oh, it's 25 megahertz, the upper limit. Let's try 20 megahertz on each channel. Where we get this? Not as nice as before, but I'm inputting minus 30 dBm signals, by the way. And the phase, I've not altered the phase at all. Take this channel down to 10 megahertz. Not as interesting as the lower frequencies, so let me just go back 40 kilohertz and 80 kilohertz. And now let me change the phase shift. I'll change the phase of one channel. See it moving now. We're turning it over. You see it's turning over that way. It's very good, this Sigland. I haven't, it's brand new actually, but you know, I've had it about, I don't know, at least 4 years. But like a lot of equipment, it doesn't see the light of day very often, so it's brand new. It's still got its protective cover, and it's pretty good. You can make your own signals up, arbitrary waveforms. Yeah, let's just press the ARB button, and that changes the signal. And let's just put it back on sine. Take it out of XY mode and just let it show the sine wave. And then if I press ARB, it should show a, and it's not. Are we on, what channel are we on? I think I changed on the wrong channel, but so try that again. There we go. I was pressing the wrong button. That's the like staircase, which is an arbitrary waveform. Quite interesting. And it does all other functions like noise. You put a noise signal in, varying frequencies, pulse, and then a ramp or triangle, and then the normal square wave, sine wave. But the arbitrary waveform's quite interesting. That's a 1 meg signal with a phase of 144 degrees. I thought I would just show you a few more Lissajous figures, and this one I'm modulating. And if I change the modulation, we can change the result. This is without the modulation. This is 2 sine waves, 1 kilohertz each, but 90 degrees, well, 89 degrees, let's make it 90. 90 degrees out of phase, we get a circle. If I change the phase, you'll see what happens. And if we get to 270, it should be a circle again, which it is. 270. Let's see if we can increase the amplitude. Okay. If I now increase the amplitude of one of the signals, we can make it larger along the x-axis, and then if I change to the other channel and select amplitude again, and we are actually at the limit now. I can't change that anymore in that direction. And that's the limit the other way. You can hear the relays clicking now. Let me just change the power of this one and get a circle. So you were talking about in your email about the it was your Lissajous figure was only one wide and high, I think you said it was. Well, if you increase the input power to the scope, you will get a bigger display. So, just out of interest, there's the two signals. And we're just sort of turning through that very slowly now, so you can actually see it, what it's doing, how it's formed. If I could slow it down more, you would see it start, position, unfortunately I can't slow both channels at once on this Siglant. Well, maybe I can, but I don't know how to at the moment, so let me just have a look. No, I don't think we can. I need to turn this. That's it. And then just reset it. That's back to our circle. And we need to let me go back to 1 kilohertz. Actually, I want to move it up just slightly different. So, right, that's what I want. I've just moved it and changed one frequency by 1 hertz. So, just to show you again, they're both 1 kilohertz. Now, if I alter one frequency by plus 1 hertz to 1001 hertz, that's the effect you will get. And that's 2 hertz and 3 hertz and 4 hertz, 5 hertz, 6 hertz, 7. That's still 7. You can see it going through the probably 7 changes there, maybe more. It's very interesting, that one. Very symbolic, isn't it? I think it's mesmerizing me, actually. I think I could watch that all night. I'm just hypnotized by it. Okay, 8 hertz. It gets a bit more complex. 9 hertz and 10 hertz. And we can go on and on and on and produce some really fascinating shapes. And let me zoom in a bit, you'd see it better. That's a good one. It's like something breathing, isn't it? Well, that's a good one. It's actually changed. It looks like it's changing phase there. It does look like the phase is changing, which will happen, of course, because the signals will be out of phase. If we go to back, we can see the difference. So there is a phase shift. Now let's move back down to the bottom there. I don't know why it moves back down to one corner. That's a really interesting one, and that is 14 hertz above 1 kilohertz. And then it'll just start to speed up as we go higher and higher. And it won't really change till we get to some significant number. Like 30, for example, it starts changing. If we go to 40 and 50. So it's very interesting. 70, that's pretty weird one. 80. And then it'll get a bit boring, so let's bring it right down again. And we're back to the 1. Now you see the way that one changes. If I change the other input, again by 1 hertz, it should go the other way. I don't remember which way the other one was rotating. Let me have a look. It's quite difficult to tell, really, isn't it? Yeah, I see. It's an interesting one. And that's two ramp signals. So it's a variation on the usual sine wave that we play with, and the others aren't very interesting. The ramp, I quite like the ramp, and that's the ramp when both frequencies are equal. That's 1 hertz difference between them, and 2, and so on. So we get a similar sort of change like we did before. That looks familiar, that one. but before we used the sine wave. See, that's sine wave, and that's a ramp. I'll go back to the one, and let me put 90 degrees out of phase. It goes in the other direction. Let's go 180 and 270. Not much difference going on there. I can change the symmetry on this as well. That's 0% symmetry. That's 10%. It's quite interesting, the 10% symmetry. So it's still two ramps, and if I change to sine, it's not very exciting. It's a bit like it was before. 20% symmetry. Oops, let's go back a minute because I pressed the wrong button. That's 20. Let's try 60. Yeah, not much difference now. I want to try, that is 1/10 of a hertz different to the other frequency. (2/10) and so on. I think this one's quite interesting. And that's with the ramp, with just 1/10 of a hertz difference between the two signals, which are at 1 kilohertz and 1/10 of a hertz above 1 kilohertz on the other channel.